All right, we're going to start with the trig derivatives, and that's what the really huge bubble on your graphic organizer is for, is because there's so many of them. I could just tell you here's what they all are, but I like to explain why, because that helps you remember it a little bit better. So this won't take too long, but humor me because I want you to understand it. This is sine, and we're going to graph the derivative. So you're going to have critical points at pi over 2 and 3 pi over 2. And then this graph is increasing, decreasing, increasing. So that means its derivative is going to be above, and then below, and then above. So what that means is derivative of sine is what? What is this, the graph of? Cosine. Derivative of sine is cosine. And if you want to go ahead and put that on your graphic organizer, derivative of sine is cosine. You're probably going to want to make some flashcards. I know everyone remembers that one, but like the other ones I know are tougher. All right, so this is the graph of cosine. We're going to have critical points at 0, pi, and 2 pi. And this graph is decreasing and then increasing. So its derivative is going to be below and then above. It's going to be negative and then positive. So that's almost the graph of sine, except what? Starts off underneath. So it's actually going to be not sine, but negative sine. It's been reflected. So derivative of cosine is negative sine. You know, seeing anything multiple times is going to make it go better, you know. All right, and then this is the derivative of tangent. I know the asymptotes are invisible, but I would dot them in. Wherever you have asymptotes on the graph, you're going to have asymptotes in the derivative. If it's undefined there, it's going to be undefined on the derivative as well. So you can put in an asymptote at pi over 2 and what was that, 3 pi over 2. Now this is interesting because there are no critical points. This does not fully go to 0 here in the middle like a cubic graph would. So whenever you do this, this graph's increasing all the time. So the derivative is going to be above sea level. It's going to be positive all the time. It's going to be like almost 0 and then get bigger. Like if I draw in tangent lines, they're really steep. They get almost down to 0 and then they get really steep again. So you're going to be like almost to 0 and then go up here. And it's going to be like really high up and go almost down to 0, but not quite. It's going to be like that. And you're going to get all of those U shapes forever and ever. So what graph is that? It's twisted a little bit, but what graph are we looking at there? It's secant. The reason it's squared is because it's always positive. You have to square it to make sure that it's above the x-axis all the time. Do you guys remember secant was like, I call them smiley faces and frowny faces. Like it's right side up and upside down. But those ones are all right side up. So we square it. So derivative of tangent is secant squared. Right. And then this one we're going to do like algebraically. Cosecant I can rewrite as 1 over what? Sine. Good. Cosecant is the reciprocal of sine, and then we're going to do a quotient rule. So quotient rule is the denominator times derivative of the numerator. Derivative of 1 just be 0. Derivative of a constant 0. Minus the numerator times derivative of the denominator. And we just said derivative of sine is cosine. And then it's over the denominator squared. So to clean that up a little bit, this is all 0, so it's gone. In the numerator, we have -1 times cosine. And in the denominator, we have sine squared, which means sine times sine. sine times itself. So this is going to be negative, and then 1 over sine is what? One over sine is cosecant. And then do you guys remember what cosine over sine is? Close. Cotangent. So it's negative cosecant cotangent. So derivative of cosecant is negative cosecant cotangent. Thank you. Now, the last ones I'm just going to tell you. But if you wanted to work out the others, like for example, derivative of secant, you can rewrite secant as 1 over cosine and then do a quotient rule. This would be secant tangent. And then for cotangent, you can always write it as cosine over sine and then do a quotient rule. And that is negative. So now you're like, we have to memorize all these. I know, and don't worry, we're not done because I need to do some of the arc ones for you, the inverse trig. And just wait, you have to memorize all the integrals too. So like, I'm the messenger. I get that it's a lot. All right, most people remember sine and cosine. Sine and cosine aren't too bad, right? Okay, I call them buddies. Secant and tangent are buddies. Do you see how they have each other in them? Tangent is secant squared, secant is secant tangent. And then cosecant and cotangent are buddies in the exact same way. Cotangent is negative cosecant squared, cosecant is negative cosecant cotangent. Like you see how they buddy together? And all the cos are negative. So cosine, cosecant, cotangent, all the cos have the negative, if that helps. But I call them buddies. Secant and tangent are buddies. Cosecant and cotangent are buddies. However you decide to remember them is how you're going to have to decide to remember them.
So it's always positive for the two. And then if you have secant tangent, then you have that's right. It's all integral. If you have secant, then you need a secant tangent. So if you have an S, you need an S and a T. And if you have a T, you need 2 S's. Oh, the PSST. It's easier if you like.
If you write it out.
Yeah.
Okay.
I just understand cot. And then 2C cot. Or
I'm going to move on, but if that worked for you, I think I followed it, but if you write it out. All right. Now, product rule, quotient rule, chain rule did not go away. We're just now doing those with trig involved. So for number 1, what rule is that? Product rule. All right, the first thing is x squared. The second thing is sine. These are going to get long, like horizontally. So maybe like start at the edge of the paper. They're not a lot of steps. You pretty much just write the answer, but it's going to be like long sideways. All right, so product rule is the first times derivative of the second. So derivative of sine is cosine, and then plus the second function times derivative of the first. There's really not anything you can do to that. I mean, you could factor out an x, but like, what's the point? If we can make them better, we'll factor them. But I mean, that's like, there's really nothing you can do to that. All right, what rule is this one? Chain rule, that people mistakenly say product rule a lot. It's like cosecant got hungry and ate 2x squared plus 3. All right, so derivative of cosecant, negative cosecant cotangent, right? So it is going to be negative cosecant of all of that. Remember, the guts of the problem stay the same. Then cotangent of all of that. So it's negative cosecant cotangent of that stuff. And then you have to chain on, I'm sorry, there's a hole in the paper. You on the derivative of that stuff. So what is the derivative of the stuff in parentheses? 4x, I'm sorry. The hole in the paper there, times 4x. All right, number 3 is another chain rule. There are 3 links in the chain. The most outside function is the 4th power. Inside of that is cosine, and then inside of that is 9x. So you have 3 things being, remember it's like the medium fish eats the small fish and the bigger fish comes eats all of that. All right, first we're gonna bring the 4 down and it's gonna drop to a 3. Everything else stays the same, all the guts of the problem stays. Now we're done with that power, because people usually ask me in the next step, well, what happened to the power? We're done with that, we did the power rule. Now we're on cosine, derivative of cosine. Good, negative sine, and it's of 9x. Again, the guts of the problem stays the same. And then the 3rd link in the chain, derivative of 9x, is 9. I'm not going to require you to do anything else to that, but just please understand that if it was multiple choice, it would not get written like that. They would take this negative and put it out front of the whole thing, and they would multiply the 4 and the 9. So it would be written negative 36, and then all the rest of this. Do you guys understand what I'm saying? Okay, because I don't want you to know how to do it and then still get the wrong answer. Like they're gonna write it like that. All right, number 4, we have 2 totally separate terms. We're gonna deal with the secant and then the tangent squared. So we're gonna ignore this for a second. What's nice about this is it's just secant. There's no product rule, there's no chain rule. All you have to do is know the derivative of secant, which is what? Secant tangent. Minus, all right, tangent squared is a chain rule. The outside function is the squared, the inside function is the tangent. We're gonna do the squared first. You bring the 2 down, it drops to a 1. You don't have to write the 1, but I put it because if I don't, people are like, what happened to that? And then we're gonna chain on the derivative of tangent, which is secant squared, good. All right, this next one is quotient rule. So quotient rule starts with the denominator. So it'll be the denominator, cotangent of x, times derivative of the numerator, which would be 4, minus the numerator, times derivative of the denominator. All right, derivative of cotangent. It's a co, so it'll be negative. There we go, negative cosecant squared. And then that is all over denominator squared. This one is going to be very long horizontally. I'm going to start like all the way over here. We'll see if I can make it fit. All right, this is product rule. All that's the first function. This is the second function. And what other rule? Chain rule, because it's sine of more stuff. All right, so product rule is the first thing. So sine of all of that. First times derivative of the second. All right, derivative of secant is secant tangent. So first times derivative of the second plus the second. I am not going to make it. I'm going to have to go up the side of the paper. Times derivative of the first. This is the chain rule. The outside function is sine, inside function is 5x squared. All right, so what's derivative of sine? Cosine. So cosine of 5x squared. And then you have to chain on the derivative of 5x squared, which is 10x. Gosh, I thought I started far enough over that I was going to be able to make it fit, but I couldn't. All right, and then if you get out your graphic organizer, I'm going to show you what the inverse trig ones are, and we'll try a couple of those. Once we finish this page, we'll do a break. You have to, and because even if you make it through the derivatives, when you get to the integrals, you're going to need them. And I hate to tell you, but then in the BC stuff, there's even more stuff to know. So like you're going to need to make flashcards. I saw somebody one year put them on a key ring. She just had all her flashcards on a key ring. And I thought like, that's such a good idea. All right, so there's not all 6 of these. There's only 3 you need to know. Yes. So I probably won't, mine will go outside the box, but derivative of arc sine, 1 over square root 1 minus x squared. And here's the thing I tell everybody about these inverse trig ones. You can just choose to not memorize these. Like you can just be like, I'm not gonna know this. And on the AP exam, I'll just guess on this one. Here's the thing though. There's going to be a lot of topics like that. And if you just choose to not learn any of them, then but there's way too much in this class to learn. And you're going to have to make personal decisions about what you decide you're going to memorize and what you decide you aren't. Is this making sense? Okay, because there's just too much. And you have lives outside of this class. So if this needs to be a thing that gets let go, that might be what happens. All right, derivative of arc tangent is 1 over x squared plus 1. Or sometimes they'll write 1 plus x squared because that means the same thing. And then the last one, they used to not do this one, but I've seen it recently, is arc cosine. But here's the good news. It's the exact same thing as arc sine with a negative. So it's not like a new thing to memorize. All you do is slap a negative with that, and then you're good. That is, oh gosh, which one is that? See, I only memorize the ones that are on the AP exam. I think it's the arc cosecant. Arc secant and cosecant. Yeah, those ones aren't on the AP exam, so I don't memorize that. But it's secant. I think it's arc secant and arc cosecant are those ones. Okay, so let's try those ones on the paper. Oh, and I wrote them with arc because that's my preference, but it can also be written with the little -1. Do you guys know what I'm talking about? That means the same thing. Like sine with a little -1. It means the exact same thing. Just so if you see that, like this could also be written like this, and it means the same thing. Okay, so, except I can't change the function. There we go. I'm sorry. All right, so this derivative. It's 1 over, now I know the pattern said x squared plus 1, but it's not just x, it's 7x. So you have to square the 7x. So it's going to be 49x squared plus 1. And then you have to chain on the chain rule. You have to chain on the derivative of 7x, which would be 7, which I would just go ahead and put in the numerator. So it was a chain rule because the insides were 7x. If you were like, hey, I didn't quite get that, don't worry, I'm going to do it again right now. So arc sine was 1 over square root 1 minus, and now the pattern says x squared, but it's got to be like this stuff squared. So what would that give us if we square that? Yeah, good, 9x to the 4th. And then you have to chain on the derivative of that stuff, which I would just put it right in the numerator. That would be 6x. All right, stick with me. We're going to do these two, and then I'll give you a break. All right, this says write the equation. That means that we need a point and a slope. And our point of tangency is at pi over 3. What's that? Unit circle. Now, if you plug in pi over 3, the 3's are going to cancel, and it's just going to be pi. So where is pi? Up, down, left, or right? This is like your little compass here. Left. I always say, is it up, down, left, or right? Because that's just the easiest way to catch that. There's pi. Cosine is the x value. So -1, and then you have to take that to the 5th. -1 to the 5th is -1. All right. Slope comes from the derivative. So this is a chain rule with 3 links in the chain. First, we're going to do the 5th. You bring the 5 down, it drops to a 4th. Everything else stays put. And then you chain on derivative of cosine, which is negative sine. And I always get asked, what happened to the power? We were done with that part. We're just doing derivative of cosine is negative sine. And then what's the last thing that's going to get chained on? 3. Derivative of 3x. That'd be 3. We're going to plug in pi over 3, but watch. If you plug in pi over 3 here, the 3's cancel. That would be pi. I already have that drawn. Sine is the y value, which is 0. So that means this entire thing is going to be 0, which turned out kind of nice. Now, I'm still going to write out the whole equation just for the sake of like being thorough. So it would be y minus -1 equals nothing. X minus pi over 3. So what would that actually be? Like if this whole side is 0, yeah, it'd be y equals -1. All right, and then last one. At what x values does that function have a horizontal tangent line? Horizontal means what kind of slope? Horizontal? 0. All right, so we want to get the derivative and set it equal to 0. Essentially, it's asking for the critical points. That's what they're asking for, is where are the critical points? All right, so what is this derivative? Yep, perfect. 1 plus cosine of x. We're going to set that equal to 0. And then you would subtract 1. So we want to know where on our unit circle cosine is -1. And I already have it drawn. Cosine is the x value. So at pi. So x equals pi is our answer.